Hi, I'm Lars. Welcome back to the C# workshop. There's a lot more to talk about with classes and objects. This video will cover static members, access modifiers, it'll touch into encapsulation, we'll talk a bunch about constructors and how they have changed over the years, and we'll talk about static polymorphism. So let's get to it.
Just like the last video, this video will get you the information that is needed to learn C#. In order to get the most out of these videos, I recommend watching them in their intended order. There will be deep dive videos after the course. We're going to talk about static. Not a lot about static, but we're just going to get into the differences, what the static keyword is actually doing. Most people think about this keyword static that's sitting on a method, and in their mind, they only think, oh, if I put static here, I don't need to instantiate my class. And that's 100% true. But then their thought process stops there. And I don't know if it's because their professor told them, hey, don't think about this anymore. But static is actually very important. And I'm going to show you how important it is. Say you have a person class, which what we have. And I come in and I say int count is equal to 0. And then in person, we just say count is equal to count plus 1. And we say console, right line, count. And then we're going to put a breakpoint here. We're going to put a breakpoint here. And we're going to put a, well, first off, we need to put a loop in here. Let's run this thing 10 times. Okay. And then let's come over here and say person is equal to new person. And we'll put a breakpoint there. So now let's run this application. So person gets hit. This line gets hit. I'm going to F and person's null. I'm going to hit F11 to come in and keep this point in mind here that count is getting initialized to 0. Going to go down to the constructor. We're going to add 1 and then we're going to print out a 1 because it's for the count. And let this finish off. And there's our 1. So what happens if we add 10 of these in, right? Say we iterate over this code 10 times. Just like this. Just like that. And we start this again. So person's null, step in, count gets initialized, we go into constructor, it gets incremented. Same thing we did before. Like it's going to be the exact same code 10 times, right? We're going to come in here, count's going to get from 0 to 1, that's going to get initialized. And as you expect, we take off the breakpoints, and you look at the output, you're going to see 10 ones, one stacked on top of each other because they're a right line count. So let's take a little deeper look at this when the person is created. So when the person's created, we have a count. It is a member in person. Okay, sitting right there. And then we hit continue. And the next one that comes in, it has it too. So we're good with that. Now, if we go back to person and we throw static in here, and we put a breakpoint here, and we run this, when we hit person, right now it's set to null, but now we have the static member that's sitting here, and it wasn't there before. Like you couldn't have done this before. Like if it was null and you moused over it, you didn't see count, it just said null. There was nothing there. But now you've got the static member count, which is kind of neat. But when you step in, notice that the static member count already had a 0, so there was no reason to stop here. It just jumped down to constructor, move the breakpoint. Now we're going to increment that to 1. We're going to print it out. So everything looks pretty much the same on the first one. But when we go to the next one, static member is still there. We haven't instantiated person yet. We haven't done anything with it, but it seems to already be there. So we're going to step in. Count gets incremented. Count's equal to 2 now. And if we step over that, you'll see the static member is 2. So what's happening is when you add the static to this static resides on the class. So it's actually sitting in the class, and your instantiations are just have a reference pointer back to it. I hope now that you can see the real difference between a class and an object. Okay, an object is actually an instantiation sitting in memory, and you can do a whole bunch of stuff with it, and you can shut it down. Class, you cannot.
Hey, if you think there's too much information to remember, then like and subscribe to the channel. Then you'll have a URL that you can go back and look at anytime.
So what I want to talk about now is access modifiers. You really can't talk about classes without them. And there are 7 of them. And the first 4 up here at the top, private, protected, internal, and public, are probably most likely the only ones that you're ever going to use. These are really rarely, I should have put extremely rarely here, protected internal, private protected, and file. Now, let's just start at the very bottom. File, only code in the same file can access this type or member. To me, that is something that probably should have never been added. And the reason behind it is because you should only have one class per file. Now, I know there are people that put multiple classes in a file, but I doubt many people use this at all. That must have been something that was requested by Microsoft himself. Private protected, only code in the same assembly and in the same class or a derived class can access this type of member. So this is kind of a little weird because it says only code in the same assembly and in the same class. So that's the private side of it. And then adding the same assembly is where this kind of gets weird. A derived class can access the same type of member, which makes sense because that's protected. But the same assembly and class, I don't know. These two are fairly new, but protected and internal does make sense. So only code in the same assembly, that's the internal, and a derived class in any location can access this member. And a derived class in any assembly can access this type or member, which makes sense because that's 2 different things. This here seems like they're adding these 2 together to do 3 things. Then we have public, which is the most, well, let's flip to the other side of this. You have private, which only code declared in the same class or struct can access the member. Protected, only code in the same class or a derived class can access this member. Internal, only code in the same assembly can access this member. And public, code in any assembly can access this member. The example that I'm going to throw on this is pretty easy. I'm just going to put 4 types down here. I'm going to put 4 fields. One's going to be public int count, and we're going to use them as properties to make sure everybody can see them. Then we're going to throw a private string name. Yeah, I'm going to flip these around so that we can keep them in the right order. So we'll put the private at the bottom here. So then there's a private string name. Then there's a protected, say int age. And then we'll do an internal string, maybe address. You just need something that makes sense, and I didn't just want to put 1, 2, 3, 4. Okay, so all of these guys, every one of them will be able to be set here. Every single one of them. So let me back all these off of here like this. Let me highlight this. Let me do a Control H. And we're going to put in here, say, get set. And we're going to replace that with an equals. And it doesn't really matter. So I'm just going to put 2 quotes and that. And it's only for the selection. And then on this side, I'm going to hit Alt and Shift and click like right about here. I'm going to hit delete. And then I can just come in, hit escape, and then just kind of go like that. And the age, we're just going to put 60. Name, we're going to put Lars. Address, we'll put 123 main. And the count, we're going to put 1. Control KD. So that shows you that these can all be set right here. Now let's do the same thing in program. So let's put up here person, right? The typical person. And then we're going to put all these guys in. And then I'm going to put my mouse right in front of name and hit Alt Shift. Put my mouse down here. You see the blue lines and the red line at the bottom. Now I can type in person dot. And as you can see, two of these are getting squiggly lines. And that's the name and the age. Well, if we go back to person, let me bring person over here to the side. Person, for person, name and age is private and protected. So what do we say about private and protected? Only code declared in the same class for the private, and you're going to add in or derived in a class that is inherited from it. So yeah, program does not fall into that category, so you're not going to be able to set these here. All right. Now, let's put a breakpoint down here, and we'll put a breakpoint here. And if we run this, you'll see we start out with instantiating person. You hit F11, you're going to come down into the constructor, and all of these will happily be set. So when we come back out, you'll see, yep, we're all happily set. Address, let's change this to 124 and make the count equal to 2. And then we can set both of them. If you go back and look at person, you'll see the address change to 124 and count is equal to 2. Since you can't compile this with this, there's no reason to change these. So let's talk about now protected. So protected is when you inherit from something. So in order to do that, we're going to have to add a class. And we're going to call this class a child, because that's what they're typically called, a parent and a child. The difference between these two is if I come in right now and I say child, and we try to, and I'm going to hit Control Shift V, and that's going to give me a list of the last 9 things I've copied. And then I can select that. Now that's into the current. None of these are setting here. Now, yeah, I could try doing this. I could try to say person, new person, but that kind of takes away from the point that's trying to be made here, right? Because that would be no different than this program over here. So one thing that we're going to do here is we're going to inherit, which is a colon person. So we say we inheriting from person. You can only inherit from one class at a time. So the one thing that you cannot see is name, and that's because it is private. Now you have protected, that's where you get age. Address is internal, and count is public, so you can get to those. That's all I'm going to talk about inheritance at the moment. That will be coming in, but I think encapsulation is the first place you really need to start. So let me reset all this, and I'll start talking about encapsulation. Encapsulation is a concept, and it's not a hard concept to understand, but it is a concept that is hard to implement. And I'm not talking about something simple. What I'm talking about is to keep the encapsulation of something, because a lot of people are like, well, we can just make this public. So for instance, we just working with one thing, somebody's name, and you might start out with something like this and say, here's a name. Now this is encapsulated in a way because it's grouped together with person, but it's not protected. Otherwise, anybody can go in and change this. Anything can be done to change it. And we're just going to start working with this. So what I'm saying about this is if I come over here to say person, and we say new person, I can come in and say person.name is equal to test. Doesn't really matter what we call it. But now this has total access to it. And at any time, someone can come in and change this, change it. So there are ways to get around this. And a lot of this used to be in the old days, you say private, and you would say string, and you'd put a lowercase name here. And then you might only be able to get this back out. Okay. So here in the constructor, you might send in name, And then you could set name is equal to name, like that. Now, when we go over here to program, name can't be set because name is not here anymore. Now, you could send in test like that, right? You can't set it, but we could print it. You could say console.writeLine person name. So that's protecting that name. Once it's set, it's only set one time, and that gives you control over it. So say you didn't want just, say you had, instead of just name here, say you had first name and you had last name. And in order to start this up, you would have somebody send in their name, their first name, and their last name. Like that. First name here, copy that line, paste it, and we're going to take last and put it up there. So if you just said first name is equal to first name and last name is equal to last name, but you didn't want anybody taking these out like in a property like this, you could always say public string and just get rid of these so no one can take them out. But you want it, when someone displays this, you want to say full name or name. They would just call it name. Just name in general. You could put a little curly bracket here and say get and say return first name. Let's put this in a string. Interpolator. Last name, like that. And first name and last name here doesn't really make any sense, so let's just, set this to first name and last name. Now you see this here is going to give you some things, assignment same variable, so what you need to do here, since we're working with an instantiation or an instance, is what it's called, of this object, you can put the word this in front of it. And that's where people started putting underscores in front of this because they didn't want to put it this. Okay, so all right, so on the other side here, you're going to say test and put, last. Let's just make this first. So first and last. And then you can still say you can write line out person. But instead of just writing out first name, last name, you want to make sure this is a standard across the board. So you want to make sure when somebody prints the name out, it comes out as first, last. Right? First name, last name. So why is this important? Because say you have someone comes in and like, oh, no, we need these ordered by last name, comma, first name. Like this. Now you've got a single location that you can change to produce that data out. And no one has to go back in other code like program. I don't have to do anything in program. All I need to do is run it again. And I'd be more than happy to come out as last first. This is the power of encapsulation. And like I said, it's not hard to do, but 99% of the time, not everything is fully encapsulated. There's some parts of them that are encapsulated, some parts that are not. But encapsulation is what I call, and I'm not picking on IKEA, but it's like going to a real furniture shop and buying a desk versus going to IKEA or a Souter or something like that, and buying all the bits and pieces, and you got to assemble them all together and then go, wow, look at the desk that I built. All right. Yeah, that gives you some satisfaction that you built a desk, but you still had to buy all the pieces. Computer programming in general is very prone to this. Like someone will come by and they'll say, hey, I've been working on this person class. And someone over here says, hey, I've been working on this address class. And then you're dealing with person and address. Why don't you just put address into person and then hand somebody the person class? And we'll get into that all later. But that's the whole point of encapsulation. All right. And like I said, encapsulation is not something that you just say, oh, yeah, I've encapsulated this. I can look at it and say, yeah, it's encapsulated. It's a theory. It's a concept. It's a way of programming. So the next thing that I want to talk about is something called polymorphism. And there's two different types of polymorphism. One is called static and one is called dynamic. And we're going to talk about static at this point in time. Polymorphism means that there's something that can change, and it usually happens, or it does happen, with methods, or a lot more times with constructors. So as you can see in this person, if we were to come over here and say person is equal to new person, we need to put in a first name and a last name. So say we say first name and last name. Now, if this was a contact in her phone, we might not know the person's last name yet. I know it sounds odd, but you might not. But if we run this, you can see first name is first name, last name is last name, and we cruise on through. Not a big deal. But what if you only know the person's first name? So static polymorphism will work with any method that you have. Most of the time it's dealt with within a constructor. So if we put this here and we take out last name and you put this in like that, this would work. And this will allow you over in program to just come in and use just the very first name. However, you can't come in and do something like this and put another one here and say last name, because this doesn't work because there's already a person defined with the same parameter list. So this is called overloading a method. And as long as the parameter list is different, and we're not talking about the actual names, we're talking about the types. As long as the parameter list is different based on the types, and you could flip two types around if you had like a string and an int, you could put an int in the string, it would be fine. Then you would consider it to be overloaded. Eventually, someone had the idea to come up and say, let's just take at the parameter level, actually set the default value. And that got rid of this overload. However, and I'll show you how this runs. This will work. It just you take nothing in. It's first name still. There's no errors. And when this comes in, first name is first name. Last name picks up that default, and everybody's happy. Nobody's complaining anywhere. You have a person sitting over here that has first name and last name. However, we had people that were like, well, I want either one of these. So they did that. Now that caused on this side that you still had to send something in, because you can't, if you send nothing in, and I put in last name here, like that, or if I put a comma in here, that's not going to bring us any good luck, and you're still back in the same situation. The only thing that you've gained is that you can send nothing in at all. So in order to send in just the last name, you'd have to come back over here to person, make a copy of this. You can't just take last name, copy it, and put it here, and take first name and put it here, because they both have the same types, string and string. So what you'd end up doing is you have to make that required, get rid of the second part of this, and put this in. And for me, that's really confusing. Someone said, let's just get rid of this entirely. And when we're calling a constructor, if you want to set last name here, just put in last name, colon, and then the value you want. And I'll show you how this works. So what happens is when you call that, first name gets the blank and last name gets last name, what you sent in. So the blank came out of here. So you could pick and choose whatever you want. If you want to send them both in, you don't need to put last name and first name. Or you could just put, first name here. But this way you had the ability to pick and choose what parameters you wanted to set or not set. And again, like here's first name. So the only thing in there is not being set, so it'll pick it up first. Then the next part came in, and it's called an object initializer. And that's when you just get rid of the entire constructor, and you put in here public. And you set your last name. So we're going to capitalize these now. And you set your last name equal to empty, and you can set your first name equal to empty. And over here in program, you don't send anything in, but you put some curly braces in with a semicolon, and then you can come in here and say first name is equal to test, and you can set last name if you want, or you can just set last name or just first name. It doesn't really matter. And now when you execute this, your person has your first name is set to test, last name is set to nothing. This is a lot cleaner to look at. I mean, it really is. It makes total sense, much more than all these overloaded methods, the constructors. But this here does look a lot better, and it's easier to read. Something else is if you have subclasses, you can instantiate those in here too. This has pretty much become the norm in C#. It's easier to read. It's easier to see what you're doing. You don't have the problems when someone comes in and deletes a parameter out that you got to go back and get rid of, you just say, okay, well, it's not being set. It's not here. You're going to get a quick error and you remove it out. So that is how static polymorphism has evolved over time.
Thanks for watching the video. Please like and subscribe to the channel. I really hope you've enjoyed this video and are getting a good basic concept of what classes and objects are and how they're different. There's a whole lot more topics in classes, but we will not get through all of them in this video series. Okay, if there's something that you really need to know about, send me a line, drop a comment, and I will get that information to you. But there's just so much stuff with classes, it's hard to cover everything. In the next video, I'm going to cover methods, inheritance, and dynamic polymorphism. You're always welcome here at the C# Workshop, and as always, have a nice day.